Hello and welcome to this training session. My name is Ashraf Ayad and I'm one of the Maya support team here at Autodesk. Today's session we'll be talking about the troubleshooting of array. So a couple of things we're going to be discussing: the error messages and what do they mean, and also we'll be talking about the most common problem that customers face, which is memory, running out of memory or memory limitations. So we're going to be talking about memory management. We'll also be looking at the log files. How can we understand the log files and the crash log files? And also the diagnostics, which is the render diagnostics and the PSP diagnostics. Other last comment that I want to discuss is the black squares that we see in rendering, or sometimes the artifacts that we see in rendering, and we'll try to understand where does it come from and how to eliminate them. So we got lots of stuff to look at, so let's get started. The first thing that we need to look at is what's happening when the render gets executed. So these are the things that happen under the hood, and we don't really follow up on it unless something happens in the middle and an error message appears. So we need to identify which problem or which section that this problem came from. The Maya file will be loaded in the scene. So this is where the Maya, the application, actually read the scene data. And then this data gets translated to array, and then the final step is array does the rendering. In order to troubleshoot, or when we get an error message, we need to find out where the problem is coming from, in which step of the above one. Things that I will do to troubleshoot a file is, can this file be rendered in Maya software? So if I'm rendering a file with array and it has lots of data in it, the first thing I'll do is, okay, can this file be rendered in software? Sometimes you need to be aware that the shaders can be array shaders, therefore you cannot render them with software. So what I usually do is I load my scene like this, for example, assign a regular Lambert, just the default Lambert, to all the surfaces that are available in my scene. Therefore I know that I only dealing with the scene data. I'm not worried about the shaders, and I just modify my Maya software to become a ray tracer, because array is a ray tracer. So I enable ray trace, and I will double check my render settings from array and see how many reflections or refractions are enabled, and try to mimic that same behavior for ray tracing only in the Maya software render and see if it will render or not. So that would be the first step. The second one is I enable something called export on demand. So if the file renders with software, that means there's no problem in the scene data itself. Okay, now we go to look at the translation. So the translation, which is actually translating the Maya data file to array. There is an option in array here. Let me flip to array here for a second. Under the Options tab, and under Translation, you see here, Performance, and there is an option called Export Objects on Demand, and this object's default is off. So what I do, I enable that option and leave the threshold to 0. This is an automatic detection from array. Tell it, okay, I don't know what I'm doing. You tell me what are the objects that should be exported or not. So what Object Export on Demand does, it will look at the scene, and whatever the camera sees, these are going to be the objects or the data that get translated to the render engine. If something behind the camera, and the camera doesn't really need to see it or render it, therefore it's not going to be translated. So it will save you some time or translation time, and that might be helpful when you're doing your render. However, you need to remember that if the object that's in front of the camera, so the camera sees that object and it is reflecting an object behind the camera, it has to translate that object behind the camera as well, because it's showing up in the render. So that's one thing you need to be aware of. Okay, so that's the translation section. Now the last thing is the array render. We need to know what is the problem or where is it coming from. So we need to enable something called the verbosity. The verbosity can be done via a couple of ways. If you are rendering from the software itself, from the UI, and we go to the render batch or render current, you will see in the option box the verbosity level is set to warning by default. There is 5 of them, but if you want more details, obviously go to the detailed or the progress. The warnings will always give you the warnings, and we'll talk about all these differences now in a second, but just in general you might want to flip to progress or details to give you a little bit more information about the problem or where is it coming from. Let's move to the error messages. So we talked about the verbosities and how to enable the mental array verbosity from the mental array, from the Maya software itself. There are, if you are doing a command line render, you can do that via the following. I'm going to open my command line. I'm going to type in render space -rmr, and this is the command for rendering with mental array. And after that, I'm going to add the V for verbosity, and it has to be followed by a number, and that number will indicate which level of verbosity. So 0, for example, mean no messages. 1, only fatal messages that will appear. Number 2, so you keep adding 1, 2, and 3, and 4, and 5. So if you notice, the more info that you're going to be asking the engine to show you, that will, if you're doing a network render or you're sending to a render farm, lots of information going to be traveling through the network. So you want to make sure that you have the capacity for all this information to come back and forth, because you don't want to block or you choke your network, and therefore you cripple your render, because the render engine has to receive the data back from the render nodes if you're rendering over a network, plus all this data or all this information that you're asking it from. So usually if I'm doing something, usually the 4 or 5, the one that I use when I troubleshooting my mental array files. Let's do a quick example. I'm just gonna use a file that I know that will it should spit an error. We are using the v0 followed by the file name. You'll see starting the render, and we should not get any message because we asked it don't send me any messages, and we should have at the end render is done. Render is done. So let's do the same thing, but this time we're going to use verbosity 1. It should give me the same thing because verbosity 1 only give us the fatal error, and since the error that I'm expecting is not fatal, it's a simple file that does not have any UVs, so it's a warning rather than a fatal error. Same thing, no problem. Let's just keep going. It didn't even tell me what's going on, and it's done. Verbosity 2, it's the same thing. We'll give you all the thing, but also will give us any non-fatal error. So the verbosity 1 fatal, verbosity 2 non-fatal. But again, what I'm looking for is actually going to show up later, which is the error just regarding a no UV found. So the same thing, I did not have any problem with this file. But let's see what's going to happen when you increase the number. So it should give us a warning message. So just to retouch on this one, some of the warning messages are harmless. For example, a file does not have any, here you go, poly surface empty UV set detected, ignored. Because I'm not using any texture file on it, it's just as a color value on in the object. Therefore, an empty UV is not going to hurt my render. But this is what I was trying to illustrate in here. When you increase the verbosity, you will start seeing these messages. Verbosity number 4 will print information message about the scene itself. So let's see how that's going to work. So now we see this all kind of information came. Message that we're going to be talking about in a minute. All this information coming in. Sorry, that's the render time here. And of course the triangle counts. So all these are valuable information for you when you're troubleshooting your files. I'm not going to do any more of the verbosity level because this file does not contain any more messages that or other messages that will produce. So 4 was 5. But again, to recap, you can go for 5. There is another option here I might as well mention. And you can say verbosity off. This means there's no information coming in, as if you do 0. Or you can do on, and it will give you a little bit of more information. That's it for the verbosities. Talk now about the message format itself. So here's a message that will appear as if we looked at it right now. It will something like this, right? So what these messages means. So first, it'll be something similar to this, right? And we wrote down all the these three letters. What do they mean in on our website, which is the Maya blog, or it's called the Maya Station. It's right here, mayastationtypepad.com, and it's an Autodesk blog for Maya. And I placed all the mentor messages in here. So API, for example, stands for what? DP stands for database. API, if it's an API error, most of the time it could be a bug. DB is the database itself, and so on and so forth. So look it up in our blog if you need all the list. But just for the message itself, you'll get something like this: the API, and then followed by a number, which can be 2 characters or more, and this number of the machine on the network itself. So machine 0 is always the client machine, okay, and then followed by a dot, and this will separate the host number and the thread number, and of course followed by that this can be 2 characters or more for the thread number, so that the thread number. And then here's the error message itself, the word error, for example. It could be error, fatal, warning, info, progress, and so forth. So here's I'm trying to cut that number for you afterwards. So it's a it's going to be followed by 7 character for the fatal error or warning code numbers. And let's dissect them a little bit. Numbers are unique to each case or each problem. It will start by example for this. The 30 means API, so that's why there is an API here followed by a 30. And then the 30 level, the number that followed the first 2 digits is, for example, the message itself, and then followed by the severity. So 1 is fatal, 2 for warning. After that, you'll have 3 digits that is unique to that specific problem. This is what means to us is this first 3. This is what we can understand. The last 3 we don't really distinguish unless we start dissecting the file. Okay, so this is how we read the message that comes out of mentor array when you're rendering. One of the most common issues that we see is mentor array will run out of memory. This problem can happen to it can happen due to lots of things. But in general, just because of how the way files are getting constructed these days are getting heavier and bigger and bigger and bigger, so there is the memory allocation that becomes a hot topic. You want to use, if you can obviously, use a machine that can allocate more memory as possible, which is the operating system that can support 64-bit like Linux or Windows. Mac, however, when you use an application that supports 64, you need a software that can accommodate that operating system. For example, Maya 64-bit on Windows 64, and the same thing for Linux. However, with operating systems such as Mac, the application that sits on it is Maya of 2009, as for today, that sits on a Mac is a 32-bit application. Therefore, is not going to max to the memory available. The maximum it will reach between 1.8 or maybe 2 gigs at tops. So therefore, even if you put more RAM in it, it's not going to reach that. So this is something that you need to understand. If you really truly want to use all the available memory, that more than 2 gigs available on your machine, you want to make sure that you're working with operating system that can support like Windows 64 or Linux 64 that can have an application such as Maya 64. So this is an important one. When rendering with mentor array has the ability to render only parts that it needs, and then if it hits the ceiling, or if it's a maximum memory, it will start something called flushing. And you'll notice messages such as this: memory progress seen, cache flushed, blah blah blah, and will start counting. In some situation, it will survive the flush, but in other situation, if it hits the ceiling of that memory problem, the operating system take priority and it will kill mentor array. So the flushing itself is a matter of seeing what do we need to use. For example, if the mental array start to get to that memory problem, it will start, for example, unloading the texture files or the modules that is not currently using, and therefore it will go to a stage that will start flushing that memory, and after that it will use it for other stuff, for example tessellation or others parts of the geometry. So the virtual memory is something that can become very useful when you work with mental array. Is that usually the virtual memory is larger or actually bigger than the actual physical memory that's installed on the machine, and the good thing about that is it gives the impression to the software that there is more memory than it actually has. And this type of memory, which is the virtual memory, requires that the memory can be swapped to disk in order to restart later. That can give you a little bit of a drop in your performance, but it's not something that is majorly in concern. However, it's very beneficial because in the end you'll finish the render job. A general rule of thumb, you want to have double the size of your physical memory to be your virtual memory. So if you have 1 gig of RAM installed, you want to have something like 2 gigs of RAM as a virtual memory. As for the memory limits inside of Mentoray, Mentoray has a built-in default to use 80% of the available memory in your machine. This can actually be found if you type in Maya, select Mentoray globals, and you will find that node in here, and memory and performance, and you'll have the memory limits. I have 1 gig on this machine, so it's going to take 800. So it's 80% of what's available on that machine. So what you need to remember is that in some situations when memory allocation is very tight and you need a little bit more than that, what's happening is if you render on the default or you just leave everything to default, Mentoray will go to that phase that is keep asking for more memory and keep asking for more memory, and the operating system, of course, at the end will say, I can't give you more, I need sorry, so Mentoray will start flushing first, and if it doesn't succeed in recovering, it will ask for keep more memory, and the operating system take premises over it, so it will end up failing to render. You can specify obviously how much memory that you can use, and as I showed you from here in Maya, but you can also do it from the command line by following adding the flag -mem, which is for memory, and then followed by a number, for example, number of megs. So if I have 1 gig, I'm just going to use 500 megs for my rendering. In some situation, that could be the answer for escaping from that bottleneck that you might be facing, because you will end up with a slower render because the amount of memory that we're giving it is less, but in the end you can survive that memory problem and you will have a render at the end. Of course, if you are rendering most of the time, do the rendering from the command line rather than the UI itself, because the UI, that's a hit on the memory itself, because it needs to add that in the memory allocation. And of course, if you have access to Mentoray standalone, that would be the best memory performance. Now for tuning up our render, let's go to the render options itself. In the render options, if you open the option box for rendering in Mentoray, you have something called the tiling, which is right here. For auto tiling, it's by default. That will influence the memory consumption. The tile size is basically determining how much memory it will need to tessellate that specific tile. If that tile is small, you basically don't need all that geometry that's surrounding around it. So sometimes lowering the tile size can be beneficial. So it can be adjusted from within the render options as well. Displacement maps, and something that I see it underused a lot of this option. When you're having a displacement on your mesh object, try to use the calculate bounding box. Click on that box. For example, let me go to my Maya scene here. Click on the object. Under the attribute editor itself, there's something called displacement map, and if you scroll down, there's calculate bounding box. I don't have a displacement on that file, but if you do, press that button, because this will help mentor ray determine how far the rays should shoot out. So you don't really need to, shoot more rays that you actually need to for that specific file. That will save you some memory as well. If you have a primitive object such as plane, this option might not be very beneficial. It's very common that if you use an object that's coming from Mudbox, for example, and it's an organic model that have displacement and what have you, I would usually check that box before I start my render. Now let's talk about log files. So the first one is the render log, and this is saved in your my documents folder. So for example, I'm on PC right now, so it will be under documents setting, my name, obviously the username, my documents, and followed by Maya. And this is the file that we're looking at, is my render log. So sometimes if I troubleshooting something, or if it's getting too big, just delete it, and the next thing Maya will render, it will put it in there for you. So it will always be there, and it will capture all the information that what happens when you start rendering. For example, I just captured a little bit of that file, starting with Maya, mentor ray version, and also that's one also important thing. You want to make sure that you're rendering with the proper mentor ray version that comes with it. So because sometimes there's a conflict between versions, you want to make sure that this file that was created in that version, make sure you render it with the same one or higher. And of course, how many threads that I was using, and it gives me a lot of information about the file itself and what was in it, and at the end where is spitting that file images, or sorry, the image file is. Alright, so that was for the actual render log. There's another one which is the crash log. If Maya crashes, it will give you a crash log. We need to identify where is that, and I will show you right in a minute. But it is really important to Autodesk, if you are experienced that you submit the CER report with providing them the email address and that crash log. So if you need to find out where that sits, go to Start, Run, and type in $temp followed by $. It will give you all the temporary files are, but an example, these are the ones that we're looking for. The Maya crash log and dump log and OPT. So these are the three files that the developers will be looking for when they're troubleshooting their why that happens. Okay, so this is for the log files, render log and crash log. So let's talk about the diagnostics. The first one is the render diagnostics, and it's an option available for you in the rendering menu under render, run render diagnostics. Right here. So it will look at in the file, and we'll say a couple of warnings here. The Lambert SG has a slot of an external shader that we don't have, and also it does not have any materials. So in ideal situation, when you run your render diagnostics, you should get something like this 0 messages found. All right. So this is an ideal situation, obviously, but you also should run it to see other messages that might appear. For example, for speed memory, you should use optimize the render before you render the actual file. Sometimes if you have big size files, texture files that is, it will say maybe you should optimize these texture files using the IMF copy, or do it automatically via Maya and the settings and preference. Under rendering, optimize file textures. If this is an auto conversion, you can do it specifically per file using the IMF copy, or you can just let Maya do that automatically for you. If we want to do more diagnostics specifically for the scene that we have available, a couple of options available for us. If we put this to mentor ray, under the option tab, and you'll see the diagnostics. So the first one is the diagnostic for the samples. And for order to see that, you're going to have to render the scene or the render view. Just a quick render, and you will see something a little bit different once we enable the render diagnostics for the samples. Here you go. So you'll see there's a grid here, and there's this little samples that are appearing in the middle, and the white line. So what these means is the areas that are in black are not sampled at all, and the areas that appear gray, they're being sampled, and finally the areas that are white, these are the maximum sample values. So for example here, you can see, let me keep this image and increase my samples so we can see the difference. Let's render that one more time, and you can immediately see how the sampling makes a huge difference for you between this one and that one. Right, so this is the diagnostics for the samples. Let's talk more about the diagnostic for the BSP tree. One of the important things that can be done to adjust your render time is the BSP tree diagnostics. If you remember, in the render options the render menu under the option tab, there is another one for diagnostic for the BSP. So if I enable the depth, I just want to show you something here. For example, before I start, this file render time was 4 minutes and 26, and that's because the BSP was adjusted wrongly. If you leave it to the default option, it will be fine, or actually within that range it should be fine. But I'm just gonna show you here that if you adjust it wrongly, it will increase the render time, and then I will go back and correct it. So the message here, the default option can give you the optimum solution. Unless you want to go real and tweak it, then obviously you can shave off a few minutes of your render time. So I just enabled my diagnostic depth, and I'm just going to render that scene again. The diagnostic face itself rendering is very fast. It's not compared to the actual scene elements, so you don't have to worry about that. So the diagnostic, we took about 16 seconds to render, and here's starting the problem. You can see lots of reds in here. In an ideal situation, what we're looking for something that looks similar to this, right? You don't want to see lots of red in your rendering diagnostics. You should see something like a checker pattern of the oranges, some blues as well. So what we can do to see that, or to adjust that, once we enabled the render diagnostics, we can look at the output window, and we start seeing stuff like maximum depth and the average depth. So let's go adjust that a little bit. Select my inventory globals. Under the acceleration, and now we have the BSP size and the BSP depth. So just comparing it to the output window again, I can see that this is too low. So let me adjust this a little bit, going back to the default values, and render again. Okay, this is getting much better. Remember, the diagnostics itself was 17 seconds before, now it's 7. So let's disable the diagnostics and go back to full mode render and see how much that will give us in a difference. So the first one was 4 minutes when we rendered it. This one is 15 seconds. The big difference, and that can help you a lot when you're working with the files that you want to render with. So just to recap again, enable that in your render options and compare the output window with whatever you have in your scene file settings. Rule of thumbs, if there's a big difference between the average leaf depth in the scene, that you need to increase the depth a little bit to get closer to that number. If the BSP depth is too low, it will not allow the actual subdivision of the tree to go down further down. That's why it will give you longer render. So this is it for the BSP diagnostics. Just a quick note here about the meanings of the colors. The red means that we have reached the maximum of the depth of that BSP tree, and the orange means the BSP tree is perfectly balanced. So that's why when I was looking at my render previously, I was just seeing, oh, there's nice lots of greens, lots of blues, some oranges, some reds, a little bit of here, a little bit there. That's fine, but this is what the scheme that you really want to look for at the end. So let's go to the next topic, which is the render artifacts. There's a couple of things that show up in render sometimes here and there, and we need to identify where they're coming from, and sometimes they call them the black pixels. So depending on the pixels itself size, if it's small pixel size like this is we refer to it as an N, or not a number. It can sometimes be white pixels as well. I've seen that a couple of times. This is a scene specific file. It could be due to a number of issues. It could be the shader, it could be something in your render settings, something out of range for the values to come back to mint array. Sometimes the geometry doesn't have UVs and it has a texture on it and can produce that. In the scene element, you have to sometimes, if you want to fix it, one of the solutions that could be a solution, again, depending where the problem coming from, is to export all the elements and re-import them again as OBJ, for example, or something like that, and reconstruct the file and see if that happens again. Sometimes I can reset the render settings and see if it's something in the render settings. I can go to the default just to show you how to do that real quickly. If you open your render setting and go presets, load presets, the default setting, and it will reset everything to default, and see if that might help a little bit or not. However, big missing blocks such as this is something different. This is when you're rendering on render nodes. For example, you have master machine and a couple of slaves, and one of the slaves dies and doesn't return the signal or the render bucket back to the machine, so it will come out black. You have to examine if that happens, then you know it's like a big chunk of missing on a render network. You know that one of the slaves died and did not bring you back that render bucket. Sometimes we report every now and then the most common problems that we see with Maya or Mentoray in general in the Maya Station blog. So I'm really excited to talking to you guys, and I'm hoping to talk to you more. Thank you.